We will learn how to use point-slope form to write an equation of the line, how to write an equation of the line given 2 points on the line, how to write the equation of horizontal and vertical lines, how to use a point and a slope to graph a line, and how to write linear equation that models data.
Point-slope form logical evolution. I just wonder, if I would have a regular point and slope which would allow me to find the second point and line would be stable, then I suppose to have an equation to describe this line. And instead of special point, like in previous section, y-intercept, I will use just regular point. And this is what we would call the point-slope form. When we will develop this idea, after that we will talk about 3 forms of the linear equation: the point-slope form, the slope-intercept form, and the standard form. And we will be ready to practice how to use the point-slope form to graph an equations. And after that, we would be able to write the equation of the line given 2 points on the line, any 2 points on the line.
Modeling. If we have a point like this one with coordinates -2, 2, and if we draw the line to this point, line is not stable. And if we have a line with a slope, we don't know the location of this line. But if we combine point and slope, we will see a second point, because slope allows us to find the second point. Now we have 2 points for the line, and line is stable. It is similar what we had before using y-intercept, but now we have just a regular point with coordinates -2, 2. I want to emphasize we use a regular point and slope in order to get a stable line. Algebraically, we can describe this process using what we would call the point-slope form. Y minus y first equals m times parenthesis x minus x first. It's arithmetic reading, where m stands for slope and x first, y first coordinates of any point from the graph. In this particular case, point-slope form for this particular line will be, but we have to use algebraic reading, y and -1 times +2 equals 1/1 times parenthesis x and -1 times -2, where 2 is y first, which is y coordinate of the first point, and 1/1 is the slope of the line, and -2 is x first, which is x coordinate of the point from the graph. Let's go deeper into this point-slope form. X first is -2, y first is +2. This is coordinates of point from the line, first point, and m is slope, 1/1. Look, if we would simplify the right side, then we will have y and -2 equals 1, and then parenthesis +1x and +2. This is point-slope form. And if we decided to remove parentheses for some reason, 1 times x, 1 times 2, then we will have y and -2 equals +1x and +2. Moving -2 from the left to the right, we just isolate y, and now we have y equals positive 1x and positive 4. What do we have now? Slope-intercept form. Slope-intercept form. Now 4 is y-intercept and slope is 1 over 1, this line. Exactly what you can see from the graph. Furthermore, now if we can move positive 1x from the right to the left, then we will have negative 1x and positive 1y equal positive 4. What it is? This is standard form. We use standard form to find x and y intercepts. And this is what you can see from your graph. X-intercept is negative 2 and negative 4, and y-intercept is positive 4. Three forms: the point-slope form, the slope-intercept form, and the standard form describe the same graph. Only these three forms use different points. But because they describe the same graph, this is why we can convert one form into another one, because all of this about this particular graph. Your project is on the next slide after demonstration. To begin viewing demonstration for project, click play on the bottom of the screen of the next slide. Demonstration for project for section 3.6, point slope form. This time our project will have three parts, and we call them project number 1, project number 2, project number 3. Part 1, it will be use slope and point to graph each equation. Part 2 will be use the point slope form to write an equation of the line with given slope and point. And then part 3 will be rewrite each equation in slope intercept form. Solve for y. So now we are going to work out part 1, project number 1, part 1. What we have? Request: use slope and point to graph each equation. Equation number 1. For this equation we have slope, which is 3 over 4, and point with coordinates 2, 3. How can we do this? First of all, let's show point with coordinates 2, 3. X is 2 and y is 3. Here is point. Now, slope is 3 over 4. You have to go up 3 units if you have space 1, 2, 3. And then you have to go 1, 2, 3, 4. And this is location for the second point. Now we can graph our graph. We can attach to one point, extend through second point, and we can correct slightly. And here is our graph. For equation number 2, we have slope, which is 3 over 4, and point with coordinates -2, -3. First, point with coordinates -2, x is -2, and y is -3. Here's our point. Now, rise and run. The same. Oh, so what do we have? Rise is +3. 1, 2, 3. And run would be, just a second, run would be 1, 2, 3, 4. Okay, but let's correct this position. Okay, now this is second point, and we can graph 1 and going through. can extend. And I want you to see something. We have slope 3 over 4 for the first graph, and slope is 3 over 4 for the second graph. So we're supposed to see parallel lines, and this is what we see. Now your project is on the next slide. Your project is on the next slide after demonstration. To begin viewing demonstration for project, click play on the bottom of the screen of the next slide. Demonstration for project number 2, or demonstration for part 2. In part 1, we graph our graphs. Now we have to use point slope form to write an equation of the line with given slope and point. Here is point slope form. What we need to do, we have to replace slope by 3 over 4, and here is x first, y first, coordinates of our point. This is x first and this is y first. This is what we are going to do. X first is 2 and y first would be 3. Okay, now let's look. Do we have in our warehouse equation which would satisfy our conditions? It looks like yes, we do. This one. Now let's check, is it true or not? Here is x is 2 and here x is 2. We have to subtract 2. Okay. And here is y is 3 and here is y is 3. So this is our first equation. We don't need to simplify because coordinates were positive. Now let's talk about problem number 2. In problem number 2, what we have? Slope is positive 3 over 4, but x coordinate is negative 2 and y coordinate is negative 2. So we have to use equation from the warehouse. And let's look what we have here. Y is negative 3 and here is y is negative 3, coordinate of the point, and x is negative 2 and here is x is negative 2. Now we just need to simplify. We need to remove parentheses. As a result, negative negative give us positive, and here is form we simplify. So now what we have here, y and positive 3, and here is x and positive 2. Your project is on the next slide. Your project is on the next slide after demonstration. Demonstration for project part 3. We have to rewrite each equation in slope-intercept form. Y equal mx plus b. Practically, we have to solve each equation for y. Equation number 1. First, we have to remove parentheses. We have to use distributive property. 3 over 4 times 1x and 3 over 4 times negative 2. Then we have to isolate y. So we have to move negative 3 from the left to the right. As a result, we will have y equal 3 over 4x and negative 3 over 4 times 2 and positive 3. Now we have to simplify constant terms. We have to add positive and negative numbers. As a result, we will have y equals 3 over 4x and positive 1.5. Now we have slope-intercept form because 3 over 4 is slope and positive 1.5 is y-intercept. Problem number 2. Similar. We have to remove parentheses distributive property first, and we will have 3 over 4x and positive 3 over 4 times 2. Now moving positive 3 from the left to the right. And we have to simplify, combining like terms, practically adding numbers. As a result, we will have y equal 3 over 4x and negative 1.5. 3 over 4 is slope and negative 1.5 is y-intercept. Your project is on the next slide.
Example number 1. Find the point-slope form of the equation of the line satisfying the given conditions and use this to write the slope-intercept form of the equation. Slope is negative 1 over 5 and passing through the point with coordinates negative 5, negative 4. To write an equation of the line, we need slope. Do we have slope? Yes, we do. Slope is negative 1 over 5. And we have point with coordinates negative 5, negative 4. It's regular point. Let's mark this point as x first, y first. Now, because we have regular point and slope, we have to use numerical values for the slope and point in slope-intercept form. We have to replace m for negative 1 over 5 and y first for negative 4 and x first for negative 5. And removing parentheses, we have to simplify. As a result, we have y and positive 4 equals negative 1 over 5 parentheses x and positive 5. This is point-slope form, but we have to convert into slope-intercept form, so we have to solve for y. But before we'll solve for y, it's a good idea to remove parentheses, so we have to use distributive property. So negative 1 over 5 times x and negative 1 over 5 times positive 5. When we remove parentheses, next step would be we have to isolate y. We have to move positive 4 from the left to the right and simplify one more time. As a result, we will have an equation y equals negative 1 over 5x and negative 5, where negative 5 is y-intercept and negative 1 over 5 is slope. Example number 2. Find the point-slope form of the equation of the line satisfying the given conditions, and use this to write the slope-intercept form of the equation. Line passing through 2 points, negative 5, negative 4, and negative 10, negative 3. We have 2 regular points, and we remember that in order to write the equation of the line, we need slope. In this case, we don't have slope. This is why we have to start from finding the slope. Let's copy formula for the slope, and next we have to substitute variables by the corresponding numerical values. Y second is negative 3, y first is negative 4, x second is negative 10, and x first is negative 5. And we have to simplify, and slope would be negative 1 over 5. After that, we're ready to write the equation in point-slope form. Because we have regular points, we don't have special point. We don't have y-intercept. So let's use numerical values for the slope and one of 2 points in point-slope form. What point we are going to use, it doesn't matter. I use, in this case, first point with coordinates negative 5, negative 4. And we have to simplify. As a result, we will have point-slope form. But request is we have to write the answer in slope-intercept form. So we have to solve this equation for y. We have to convert point-slope form into slope-intercept form. First, we have to remove parentheses using distributive property. And then we have to isolate y moving positive 4 from the left to the right and simplifying. Finally, we will have an equation of the line y equals negative 1 over 5x and negative 5, where negative 5 is y-intercept and negative 1 over 5 is slope.